Hello everyone, my name is Oleg Šelajev and you're once again watching a streaming episode of GraalVM. I'm very happy that we are continuing this tradition, and today in my virtual studio I have Graeme Rocher, and the topic for today's chat is everything you need to know about Micronaut 3.0. So there was a recent release of Micronaut, which is an excellent framework for your applications, and we're gonna run through what's new and important in this release, how to upgrade, and if you have any questions about this release in particular, or maybe some future plans, or maybe some considerations why certain things were introduced, there is no better person to ask about that than Graeme, who is right here. Graeme, how are you doing?
Good to be here.
Very good.
And happy to be presenting Micronaut 3 for the first time. Should be fun. Lots of new things and bells and whistles to play with. So yeah, good stuff.
Right, very well. I'm gonna leave you the reins of the session, and yeah, please show us and tell us something that you wanted to show and tell. And then if you have any questions, please put them down in chat, and we're gonna figure a moment to talk about them with Graeme.
Awesome. Okay, so I have some slides and some other things to show. So and some demos, and as with all demos, will be live demoed. So probably things will go terribly wrong, but hopefully not, and hopefully we'll have fun. So first I want to talk about like themes for Micronaut 3. So this is Micronaut's annual major release, and we had a few themes that we want to address. So clearly GraalVM 21.2 and the latest greatest things for GraalVM is one of the keys to this release. We have done a number of different build time optimizations to Micronaut to make the metadata that Micronaut produces at compilation time from JavaC more optimized for GraalVM, and also to allow it to be more easily initialized at build time. So more of Micronaut 3 is now initializable at build time, and we have moved a lot of metadata and so forth into a more optimized format. Another major theme is standards alignments. So we are working present and future standards, as we always have in Micronaut. So Micronaut 2 supported JSR 330 and much of the bean validation API, and a variety of different JavaX transaction, etc., JPA. So we've already had like extensive support for different standards, and this release that alignment, except now we're moving over to Jakarta and also laying the foundation for future CDI support. CDI is context and dependency injection. And then in addition to that, we have an often requested feature in Micronaut where the way Micronaut works is it processes your source code ahead of time and hooks into JavaC and processes that source code, and that source code produces a bunch of dependency injection information, so it knows how to wire together your application, and that's done so in a JSR 330 compliant manner. So all the JavaX inject and in Micronaut 3 Jakarta inject annotations are supported. But obviously a limitation of that is that Micronaut had to process your source code. So if you had an existing library that was already compiled, if you wanted to make it Micronaut compatible, you had to recompile it with Micronaut in order to make it compatible if it had JSR 330 annotations. So with Micronaut 3, that's not the case anymore. Now you can import import external libraries into a Micronaut application that those libraries define JSR 330 annotations like @inject and so on, @singleton. Micronaut will know what to do with those, even though they're binary bytecode and not source code, and you'll be able to dependency inject them into your application. So bean import is a pretty important feature. And the other thing is, we also added, and this is maybe more for us framework developers, but it was key that the way bean import is implemented is extensible, because JSR 330 is just one way to define dependency injection. We wanted to make sure that in the future, you'll be able to import beans that are defined with, say, Spring annotations or CDI annotations. Part of the bean import work was to provide an API that could be plugged into Micronaut to basically allow feature extensibility and importing beans from a variety of different sources. Then at the kind of framework level, we have a whole bunch of enhancements, dependency injection, aspect-oriented programming, and finally we also switched. Well, it's a little bit more than switching to Reactor. We decoupled Micronaut from any specific Reactor framework. So Micronaut 2 was quite tightly coupled to RxJava 2. You can still use RxJava 2 in Micronaut 3, but we've decoupled from any kind of specific Reactor library. So you can, and we've made the default Reactor. And this aligns better with, and there's a number of reasons why we went with Reactor. Many of our users are coming from frameworks like Spring and have familiarity with Reactor from their time with Spring, so it makes it easier for them to switch. And in addition, Reactor has some niceties that are good for server-side programming, such as features like context propagation and so forth. So that made it a good fit for Micronaut. And this was, fairly easy to switch from, relatively easy to switch from RxJava 2 to Reactor. And given we had to make a switch anyway, because of the presence of RxJava 3, it was probably a good time to switch. So those are the general themes of Micronaut 3. So the first thing I'm going to kind of cover is the GraalVM 21.2 optimizations. So we have a new build time metadata format. And what this does is, so whenever you have a new, whenever you have an Micronaut application, so I can create one here. And if you don't know, I'm actually using Micronaut.
Can you please switch? You're showing the slides still.
Let's have a look. So let me see. Let me stop sharing that. I'm going to share my whole desktop and see if that works. Can you see?
Yeah, this is much better.
I must have clicked the wrong button at the beginning. Thank you, Oleg, for pointing that out. So yeah, I have actually Micronaut 3.0.1 installed. So that new patch release just came up as we progress the 3.0.1 line. When you create a new Micronaut application, it's the same as always with MN or through Micronaut launch. You can do it via curl at launch.micronaut.io, which provides instructions on how to do that. But in this case, I have created a Micronaut application via the CLI. And so whenever you build a application with Micronaut, for every kind of component in your project, we have a metadata format. And there's like a one-to-one mapping between when you define what's called a bean So, so for example, if I were to create some kind of, let's see, Java class here, let's call it book service, whatever. And if this is just a plain class at this point, but when you annotate anything with Micronaut, and as you can see with Micronaut 3, we're getting the Jakarta.eject annotations instead of the JavaX ones. So when I annotate that on my class here, the there we go. What happens there is I seem to have placed this in the wrong. Put it in a package. Okay, so when I define any class as a bean by annotating it with a particular scope, in this case singleton, when we compile that into, so if I do compile Java, for example, here, what Micronaut will do is it'll produce what's called a bean definition. So if we look at list build classes main Java demo, you'll see that we have a book service, but we also have a book service definition and a reference. So we get two additional classes, and this is how Micronaut looks into the compilation. And it's these metadata files that we have optimized significantly for native image. And the net result of that is now when you build a Micronaut application, so if I assemble this into a Java file, and if I assemble it into a Java file, and if we look at the relative size of that, if we look at the old Java file, you can see that it's gone a little bit of a diet in terms of being significantly a couple of megabytes smaller. And that's because in general, we have reduced the size and overall size of that metadata format that I mentioned before. Also, a lot of the, so for example, if I were to inject something here, so inject the environment, for example, into this component using the inject interface, what that will do is it'll build a kind of compilation time injection point, which will go into that metadata class that I mentioned earlier. And basically, for each injection point you'll get a bunch of metadata. And all that metadata in the new metadata format has been moved into static initializers. And what that allows GraalVM native image to do is move all that initialization and so forth into build-time initialization. And that means we have, for example, smaller native image sizes, shorter build times. Micronaut, when you build it into a native image, Micronaut 3 now is 10 milliseconds faster than Micronaut 2. So I think Micronaut 3's startup time is like 13 milliseconds or something like that, and Micronaut 2 was like 22 or something like that. So it's almost 9 milliseconds faster on average. And we expect that number to go down further as we optimize more. The first step was coming up with a new metadata format, and now in future minor releases of Micronaut, we're going to be further optimizing that build time metadata format to place more on a native image heap over time. So I think it's going to be a nice evolution of the framework in terms of using this new build time metadata format to reduce the memory consumption, the jar file size, and the size of the actual produced native image over time as we produce more and more optimized applications targeting GraalVM native image. And we expect that to continue to improve over the coming minor releases as well. There's a whole bunch of areas of investigation that we're undertaking, from moving more and more into build-time initialization, which I think that will be an interesting evolution of the framework and of the metadata format that we have today.
That's a cool collection of improvements. Did you so you mentioned that there is some classes now are better suited for initializing at build time. This is a sort of advanced configuration, as far as I know, from the GraalVM native image point of view. So
yes,
you wouldn't expect that to leak sort of into the user space of the application. This is something that Micronaut handles for your applications.
Yeah, you have to be very careful with using build time initialization because and you have to be very selective. It is definitely an advanced feature of native image, and we've kind of been very cautious with Micronaut about initializing too much in build time. So one of the goals of creating a new metadata format was to isolate the things that we know we can initialize at build time from the stuff that we don't want to, right? It's actually might be easier to demonstrate within IDEA. The reason is because IntelliJ has a decompiler, which I don't think Visual Studio Code does at this point in time. But if I were to compile my application now into just use the latest compilation data, you can see if I decompile the definition, you see that a lot of the state around dependency injection, the injected fields, the injected constructor are initialized into static initializers, right? Through the static initialization block. And this allows all of this kind of data to be initialized at build time because we know that it's safe to do so. So at a framework level, we can produce more optimized applications. And then the stuff that we know needs to execute at runtime goes within the build block and so forth. And same thing for any kind of annotation information. So we can, any of the annotation information related to the type, what annotations it has on it, etc., can be initialized into static state and stored, which benefits both native image but also other use cases in the future, whether it be even in JIT mode, it's more optimized to do it that way. So the more and that means when it comes to actually wiring together your application using dependency injection, everything is already known to Micronaut prior to executing the app, right? So that's and we will continue to innovate in that area and keep pushing and reducing the size of our native images. We have a lot more, like I said, areas of research that will be going down in terms of continuing to produce more optimized applications, because there's further analysis that can be done on the actual build time metadata, which is a potentially interesting area of research. By optimizing it further in the post kind of processing step. And those are all threads of research that we're undertaking right now.
Very cool. Very cool.
So standards alignment. So as I mentioned already, and as you've seen in this example, so we have are undertaking a lot of work. We have switched by default to Jakarta annotations. So that includes Jakarta inject. So now we use, instead of JavaX to inject, Jakarta inject. And we anticipate continuing to do that as we align with the Jakarta E standards process. It also includes things like post construct, which we're now supporting the Jakarta.annotation package, which contains, instead of JavaX annotation, post construct. And it's actually very interesting how Micronaut handles this. You may have noticed that because obviously it's important for backwards compatibility that we support both JavaX inject and Jakarta inject. So if we were looking previously at that example, you'll see that actually in the annotation information at runtime, we're actually storing the JavaX inject versions. So we transform all of those annotations from their, it's just another source code DSL, but at runtime they're represented the same. So we don't have, that's one of the advantages of doing things at build time, is that we can support multiple annotation models, and we don't have overhead of making runtime decisions like, if Jakarta inject present, then do this. If JavaX inject in present, do that. And adding all that kind of runtime overhead that a traditional framework would have to deal with in terms of supporting newer standard namespaces, as well as being backwards compatible with previous approaches, right? So that really helps that Micronaut is build time oriented in that sense. There are some namespaces that haven't been migrated yet, and we anticipate that we'll be migrating those over time. So we don't yet support Jakarta.validation or Jakarta.persistence, but those will be in the future minor releases. We'll be adding support for those namespaces as we gradually migrate all of the different use cases to the Jakarta namespace. So that was a major theme and a major undertaking to move to all of those, but it sets a path for the foundation that we need going forward in the future, including the foundational work on CDI. So a lot of work in Micronaut 3 has been around setting the foundation to support CDI Lite, which is an upcoming version of the context and dependency injection stack. And there were many features that exist in CDI that didn't exist in Micronaut, so we have had to do significant work to lay the foundation for that. And we continue to work with the CDI specification process to come up with a CDI 4, which will be the next revision of CDI. And it's anticipated that Micronaut will implement CDI Lite for that revision, along with Quarkus and whichever other vendor is going to implement it. And that'll again be important for future standard support and adoption of Micronaut in scenarios where standards are a requirement. So we continue to evolve. So we'll support the Jakarta .enterprise name package and much of the CDI programming model in an upcoming release of Micronaut. So that should be exciting in terms of standards alignment.
That's very nice. Yeah, okay. The demo sounds good right now. I just wanted to ask something about CDI Lite, but I think we can safely keep that until later, after all. Yeah,
that's fine. We can leave discussion to the end. I had a demo of bean import, so I'd gone on about how in this example here, where you see where we have a class that's part of your source control, we are able to produce a bean, that's injectable, and you can inject different components into it, and run logic after it's constructed, and manage the life cycle of the component, and so forth. Supporting the full kind of JSR 330 dependency injection set of annotations, as well as post-construct, pre-destroy, and all the lifecycle annotations. Now, this works on source code that you're in charge of, but if you have a project that is external in a library, then you really only had in Micronaut, you really only had a couple of options. You could kind of fork the library and recompile it, which not many people are prepared to do. Or you kind of rewrite it. So there are actually many libraries out there that are based on JSR 330. So it's nice that you can now import those into your Micronaut app. So for example, the actual JSR 330 TCK you can import it. For example, if I add a dependency in here, then to the JavaX.inject TCK, theoretically at that point I should be able to come to my application class and then make it a bean, and the TCK includes a, I believe it's called a inject car, and what we can do here is inject car, which is from the TCK. So I'll import for inject and import for the TCK. And what I'll do is I'll add an event listener here that runs when the application starts up. And just do system.out.println car import, something along those lines. So I'm trying to inject car, which is from the TCK. If I were to attempt to run this right now, you'll see that it actually fails because no such bean of type car exists. So we can't actually inject the car. But what you can do is you can say import, and then you can say packages, and then you can say inject all of those beans that are inside this package. And what will happen there is let's see if I import packages. Let's run this again. Hold on. It'll essentially import the TCK. I think I might have chosen the JavaX inject one instead of the Jakarta one. But basically, you can import the TCK or anything that has a library dependency, and it will build any kind of additional bean definitions, import them from that third-party library, and include them as part of your application automatically. So that's a nice feature of being able to import. The actual import annotation is described in the user guide. So we have a new where is bean import section, and yeah, probably what I'm missing is the annotated. Let's just copy this sample. Be easier. And then it will work, right? So now, as you can see, it imported the car, and it's a convertible. So the car is a convertible, and the implementation of the interface car is convertible. And we managed to import all those beans from these two different packages that are in a third-party library. So you have to specify which beans are with which annotations you want to import. So that's what the annotated annotation. By default, I think it just looks at scope and qualifier, and you can put star to say import every single class. So I think part of the TCK into the JSR 330 TCK is that every class in that TCK is a bean, so we have to import everything. and there's 2 packages, so it doesn't recurse by default. So you have to go through and define which packages you want to import explicitly. And the way it works is at build time, Micronaut will actually produce the addition, all the beans from that JS330 library. So you'll see there's like a convertible bean and fuel tanks and seat belts and spare tires, and all of those are computed at build time and injectable into your application, even though they're already compiled libraries. So the foundational for this is to then make this extensible so that we can in the future basically import beans, for example, from Spring libraries or from CDI libraries as well, right? So this is like foundational. So it's a large part of the bean import feature was to essentially make it extensible to other types of dependency injection component models.
That is pretty cool, right? So now as a library author, not only can just offer you like sort of classes that you want to consume in your application, but they can actually wire them together using a dependency injection mechanism and then give you sort of the object graph, right? So you can get a card which is pre-configured with other beans as well, like everything is injected there and it's ready to go. So instead of, you can inject an Uber there.
Exactly.
That is,
and the cool thing is obviously if you have like a requirement to support Spring and Quarkus and Micronaut, you can use these you just use the JSR330 annotations, and all of those frameworks will understand the library, and you can import it and dependency inject everything together and potentially make a portable library across all the frameworks, which is quite useful.
Cool. I imagine if you have an API for something and you would have a client library to that, it makes sense very much to kind of make it package it this way, because then you get a pre-configured client to your, I don't know, like a service that reads tweets or I don't know, talks to your cloud deployment or something. That's very neat, a neat feature. I like it a lot.
And as I said, a lot of it was to make it extensible. So we actually have an API that you can hook into with the compiler, and in the long term, we'll add support for importing Spring beans or whatever other third-party annotation model we want to support. So it was an important foundational feature for Micronaut 3. So now let's talk about dependency injection. So there's a lot of different improvements to dependency injection. We have much broader support for generics. We have support for qualifying by annotation member, limiting bean types, beans from fields, the BeamProvider interface, which I really like, and the any annotation. So let's have a look at some of those things in action. Maybe we'll continue with the kind of car vehicle concept that we are going, and just forget about books for the moment. So let's create, for example, to demo that kind of first thing, generic injection. Let's create some example application here. So what you can do is, let me say you had like a vehicle class here, and it accepted a generic type, T, which extends from engine, and we don't have an engine class, but we can create one. So let's do engine, and maybe it's an interface, and then perhaps we have an implementation of this interface called V8 engine or something to that effect. Engine, and maybe we're all green, and we have another one called electric engine, which also implements engine. Then we can come in here and we can say have a factory that returns different types. So let's do private finality engine and create a constructor, and maybe add a getter for that. Oops, I already have a constructor. There we go. So we have my engine. So that's my vehicle type. And what you can do is maybe we have something like a vehicle factory or something along those lines. And this is going to be a factory type, like so. And what we can say is we can have one bean, which is a singleton, which is a vehicle of type electric engine. And it's going to be an electric vehicle. So, and then we can return a new vehicle. So with a new electric engine, something along those lines, like that. And we can have a second bean that is a V8 engine, and obviously we have to make sure that this is a V8 vehicle, whatever. So we can have two different beans with two different generic types, and then and then we can based on those generic types, we can independently inject at any injection point the type of vehicle that we want. So if we only want electric vehicles, electric engines, we can inject that like so, and output. Oops. No, okay. And output the electric. Okay, so let's have a look if that little bit of dependency injection with generic, etc., worked out. And have a look. So debug console. Hold on. I stopped. I think I might have had it running already. Okay, so as you can see, we injected the electric vehicle. Probably to make that more illustrative, it's probably worthwhile making something a little bit more interesting. Like we have a start method here that we're going to implement in each implementation. So here we can say implement method like that, and on the electric engine, quiet electric sound or something. The electric cars they don't make much noise, do they? And then on the engine we can do the same and implement that. Vroom. Very noisy. Okay. So when I do start on the vehicle, and I don't think there is a start method on the vehicle, which we can create one. There we go. So it's going to start the engine. Let's do something along those lines. Start it. Okay, so let's just call vehicle.start, and my application and see how the wiring affects behavior of my application. Okay, so electric sound appeared, and now obviously I can alter the generic types if I want, and I can say instead I want the V8 engine, and just maybe just name this vehicle. Restart and alter how my application is dependency injection and wired together. You can see that now it's got room as a different bean is being injected based on the generic type arguments. So it's very convenient to be able to specify different generic type arguments and have that just dictate which component gets injected. We had not great support for this in Micronaut 2, and now we have very comprehensive support for generics and generic injection. So that's, I think, pretty cool that you can do that now. And a big improvement overall to the dependency injection framework within Micronaut. Now, in addition to that, you can also inject based on ionization members. My two vehicles here don't have a particular qualifier, but you could have qualifiers here that were, engine type equals V8 and have an enum or electric, and use the annotation to dictate which one to inject by essentially saying on the injection point, inject a electric vehicle. Instead of using the generic types, you can actually use annotation members, but I'm not going to demo that for now. What I'm going to demo is limiting bean types. So when you have a factory like this, and by default, the bean type is essentially whatever the return type is. In this case, a class of type vehicle, and whatever its superclasses and interfaces types are, right? So imagine a scenario right now where I had some kind of internal interface where, I don't know, let's say I had a interface here called vehicle internals, and I made vehicle implement vehicle internals. But I didn't want to expose this type to be an option in terms of dependency injection. So I don't want to be able to, anybody to be able to inject vehicle internals at any point in time. You can essentially control that now with Micronaut 3 by saying a bean is typed as a specific type. And it could be an interface of the class. So we could make this a default vehicle implementation. For example, we could have a vehicle interface. This could be an interface instead. And we might have a default vehicle implementation that we don't want to expose. So what you can do is on the factory say that it's typed a particular type or one or many types essentially, and it will limit the injectable types of the created bean, which from the factory, which is very useful for defining and controlling how dependency injection is done. Another useful thing is bean from fields. So as you can see in this example here, I'm using methods in my factory, but you can also use fields in Micronaut 3. So now you can say, shorten this a bit, and get rid of that and make that a field. And you can define make this a bean, and you can define a particular, make a particular field a bean rather than just methods, right? So it's syntactically a little bit more concise and actually works very well. One of the really areas that really works well is in unit tests. when you want to define like a mock bean inside that is only valid for the scope of your unit test, you can define that in here, like some kind of other vehicle implementation, whatever can be implemented here. That is only, and you can annotate it with mock bean, and it will only apply to that field and make that field into a bean. So making fields into beans is pretty handy. A little bit more syntactically concise, but more importantly, something that CDI supports. Another interesting aspect of this is this field is mutable. So I've annotated this with single, but you can also make something that's effectively singleton by making it a final field, and then we know that it can never be changed, and therefore it's implicitly single through final, which is an interesting option as well. Okay, so and another very nice thing is the BeamProvider interface. So the BeamProvider interface is extremely useful. What you can do is inject, for example, a vehicle provider interface. So, let's do BeamProvider and get vehicle provider. Like so. And maybe in this case we use constructor injection. BeamProvider, let's see, vehicle. We generate a constructor for that. And what we probably want to do is import BeamProvider. So let's fix that compilation error. Right. So why would you inject a BeamProvider? Let's see. So why is that illegal starter type? Oh, here we go. So a vehicle provider provides you the ability. BeamProvider provides the ability to modify how your application behaves based on the presence. So I can, for example, say if present, if present, do something with the vehicle, like so. Or I can say vehicle provider, if resolvable, do something. You can also take the provider and you can get a stream of all the different vehicles, like so. So it's going to be my vehicle stream, and you can iterate over all of them and essentially find all the different vehicles that are available in my application through the BeamProvider interface. So it could represent one bean, or it could represent many different beans, right? So that and if it's resolvable to a single bean, you can of course call vehicle provider. Call vehicle provider. There it is. Vehicle provider.get to get the particular vehicle that I'm working with. So you can call get, but obviously if there's more than one and it's not able to unambiguously resolve the vehicle, you'll get a ambiguous method exception. So lots of improvements to the BeamProvider interface. You can resolve something by a particular qualifier. It implements iterable, so you can implement iterate over it. You can figure out, you can get a stream of beans. You can figure out whether something is unique or present or resolvable, and do some kind of functional programming constructs, which is really nice. Okay, so lots of dependency injection improvements. In addition to dependency injection, we have improvements to aspect-oriented programming, or AOP. The most important is constructor interception. So we have also post-construct and pre-destroy interception, but constructor interception is pretty neat. So what does that do? So basically, imagine for a moment this electric vehicle that I'm that I was, and I'm just going to roll back some of these changes that I had here to go back to what I had at the beginning. So, imagine for a minute this electric engine I wanted to make, or maybe, for example, the factory. I wanted to intercept the construction of the object, right? That's absolutely possible now. So what you can do is, what you can do is essentially define around constructed device. You can implement a constructor interception, and there's a number of different ways you can do that. So there is a around construct annotation, and what you want to do is when you want to apply this to another annotation. So, for example, let's think of some kind of around construction advice. Maybe we just call it validate constructor or something like that for the moment. So I'm going to have the annotation type, that is validate construct. And what you can do is you can add retention and make this add that in. Oops, what have I done here? Okay, need to come in here and add new from template, validate. Make this a annotation, and I'm going to add around construct to it, like so. And I'm going to make it retention, change the retention policy to runtime. And what I need is import. And import, there we go. And what I can do then is add an interceptor bean. So I can say new validate construct interceptor, like so. And I can make this a interceptor bean that intercepts the validate construct annotation, like so. And it implements constructor interceptor object. And with that, you can implement the construction of any object that is annotated with validate construct. So when you call proceed, it will return the constructed object here, and you can validate, post-validate what was constructed. So this will always return something. It will never be null, and it will always return the constructed instance. And in addition to that, you can also, prior to constructing it, you can get the parameter values, and you can iterate over those, for example, and modify them and or validate them prior to them being passed to a particular object. Let's have a look at an example of that. So maybe I just put it on my application class for, or maybe we should create some other object as a demonstration. So new from template, validate me. And what you can do is put validate construct singleton. So, and maybe inject something into the constructor so that we have something interesting to look at. And then I will I will inject this into my application here. We will have a look at what happens. So I'm going to press a breakpoint here, and if the demigods are with me, we'll see whether it gets hit. see debug console. Thread stopped at validated interceptor, so it's hit my interceptor. So as you can see, now I can step over, and we can see the parameter values that the environment that is inside my parameter values. So as you can see, whenever my validate me bean is created, the constructor gets intercepted, and basically we can step over and perform validation on the constructor object. So step over again, you can see there's the constructed instance of validate me, and we can add whatever interception logic we want to validate the parameters and be done with it.
Awesome.
So I think constructor interceptors are pretty cool. And I think that's pretty much all I have probably time to demo, Oleg.
Yeah, I think,
if you have, go ahead.
Yeah, I think this was a very interesting demo. I liked how it was the sort of the common flow, and the cars and vehicles theme is easy to grasp, and I think it was interesting to follow. You have here a couple of resources for what's new and what's exciting. I know from the release blog post about Micronaut.3, you said there, or it's like the blog post said that since it's a major release, there are a number of changes which are breaking, which is of course sort of, well, expected, right? A major version of the framework. But then it also mentioned one really cool thing, which I didn't see very much in the community before. It was the easy upgrade. Maybe you can say a couple of words about that, because that sounded very, very interesting for teams who already use Micronaut and want to upgrade forward without any hassle.
Yeah. So I have in front of me here the upgrading instructions, which are linked off from this slide. So this is the link here. And so there are, now it's important to note that Micronaut 3 isn't like a huge upgrade. If you're Micronaut 2 user, it's not like, you know, Python 2 to Python 3 or something like that. It's a relatively simple upgrade, but there are breaking changes. Some of them are related, some things I've already demonstrated, like the JavaX inject, Jakarta injects package switch. If you were an RxJava 2 user, you need to add some dependencies. There are some, you know, a few classes that are moved around, changed packages. So what we did was we worked with the folks behind Open Rewrite, and there is a Open Rewrite plugin that helps you upgrade from Micronaut 2 to Micronaut 3. So you can add the plugin to your project, whether it be Gradle or Maven, and you can run a like a dry run of what the upgrade will do, and it will actually analyze your source code, and it will do some automated refactoring to your code. Of course, we encourage you to do this on a Git controlled repository to make sure that you can roll back or whatever thing. But basically, it rewrites your code, renaming JavaX to Jakarta, changing imports for anything that's moved around, adding dependencies if things required additional dependencies to be changed, and getting you probably a long way along the way to upgrading to Micronaut 3 automatically out of the box, right? So automatic upgrade, like you said. Open Rewrite is a really cool project. It's like basically distributed automated refactoring of Java code. Only slight shame right now is it's other languages are not supported, but Java is supported great. So if your code is in Java, then which majority of Micronaut's applications are in Java, then no problem. It'll help you upgrade to Micronaut 3 from Micronaut 2 and do a lot of the heavy lifting for you.
Pretty cool. Pretty cool. I haven't seen that earlier in the wild, so to speak, and I'm very interested in trying that on my Micronaut applications just to see whether it will help me or whether it will actually completely migrate me seamlessly to the new version. Very, very good. Yeah, I don't have any questions.
Awesome.
If we have any questions in chats, please type them in. I think this is the last moment where this is sort of reasonable to expect that they will be answered. Do you have, Greg, do you have a sort of a timeline for Micronaut.4 or like any larger themes that are in like planned, or at least you want to stuck them into the next major version?
So we're working on the minor releases now, but the next major release will be in a year's time. We're focusing on a yearly release schedule. The next major version, I think, will mainly be focused around removing the remaining JavaX namespace dependencies. I don't anticipate that we will be breaking much. So I think, like I said, we need to move to Jakarta validation and Jakarta persistence. And, there'll be big releases of things like Hibernate 6 coming out that we need to support. And the other big thing for Micronaut 4 will be finally dropping support for Java 8. So Micronaut 3 is the last version of Micronaut that is going to support Java 8. So Micronaut 4 will be Java 11 and above, which will be a good thing, good step in the right direction, getting people upgrading, and also aligns with the direction that GraalVM is heading in terms of its Java 11, Java 8 support timeline, I think. Yep. But in terms of the short term, we have a lot more exciting features coming in, like kind of short term minor releases coming up. So we have like we're working on build time JSON solutions. So basically computing JSON serializers and deserializers at build time, which I think a lot of users will love, which will tie into our upcoming support for document databases, which is a big theme. And all of those like more exciting features, document database support, build-time JSON support, etc., will be in the minor releases of Micronaut 3, so 3.1, 3.2, 3.3. Okay.
Excellent. Since you mentioned versions of Java, now obviously in 10 days will be one of the more important Java releases in the last couple of years, which is Java 17.
Really looking forward to it.
Is Micronaut 3 ready for Java 17? Is it recommended to run on latest and greatest? Or if you would start a greenfield project with Micronaut, say in like 2 weeks, what would be your Java setup? Like which version you would be basing on it?
I would jump right into 17 for sure. I would, 17 has got so many awesome things. Also like improvements to startup and so forth, big changes to the programming model as well that are going to influence the way people build applications a lot in the next few years. Things like sealed classes and records, and it's really going to influence API design a lot in the next few years. So it makes sense to jump right in, I would say. And really, it's not like Java 17. There's been 16 and 15 and 14 14 and 13 before then, so it's not like, you know, it hasn't been tested out in the wild over the last few years. So it's a bit different situation to previous, you know, where we went to the previous stage where we had big gaps between Java releases. It's not the case anymore. So and GraalVM also has now developer builds for 17 out and about for you to use with native image. So I think it's a good time to jump on that release. And I look forward to presenting Micronaut plus Java 17 plus GraalVM at Developer Live as well. I'm doing a session.
This is somewhere in a few weeks, right? As well in September.
Yeah, next week in fact.
Oh, that is very, very cool. Excellent. Yeah. Well, follow Graeme more for information about his upcoming sessions at conferences and other activities. And thank you very much, Graeme, for joining me today. This was the GraalVM session about Micronaut, everything you need to know about Micronaut 3.0, a recent release. I hope you enjoyed it. I hope you learned something from it. And yeah, follow the channels, follow the GraalVM project, follow the Micronaut project. Happy hacking, and see you next time. Bye.
See you. Bye.